And let me stop a little bit more on topic about current time. To display some kind of time for now, for example, 1 hour 45 minutes and 19 seconds, we use CurrentTimeinMillis method in system class that returns the current time in milliseconds. How does it count it? It counts it since the midnight January of on the 1st January of 1970 year. Why does it take it so? Because on that time the Unix operating system was formally introduced. You can use this method to obtain the current time and then compute the current second, minute, and hours as follow. For example, if we say that the time where Unix was introduced is 0, our time will be here, current time. Now we are taking current time and subtracting this one and finding this difference, and then we are taking this current time milliseconds and dividing it into finding first of all seconds and then minutes and then hours and then days. Let us see this show current time program source code in here. For example, what do we do first? First of all, we find current time in milliseconds. As it will be a long number, we are taking it not an integer but as a long total milliseconds is system.currentTimeinMillis. It will show us time, how many milliseconds passed since January 1st from 1970 year. First of all, what we must do? First of all, we must find total seconds. Total seconds we find by dividing our milliseconds into 1000. When we have total seconds, we have to find the current second. How to find current second? We must divide all seconds into 16 and find the remainder, and that will show us the milliseconds of our time. After it, we are dividing our seconds into 60 to find total minutes. When we found total minutes, we have to find current minute. How to find current minute? The same as current second. We are dividing total minutes into 16 and taking the remainder. The same operation we do with our hours. First of all, we found total hours by dividing total minutes into 16, and then to find the current hour, we're taking total hours and dividing it into 24, as it's 24 hours in a day, and then taking the remainder as our time. And when we will run our code, we can see how much time is it now. Let me run this code. Java C show current time. Show current time. What is it? I made here some mistake. This way. Now let us run our code, and it will show time 9.13 minutes and 13 seconds. This is current time, but I think I have problems with my system time, but it works like this. What is next? Augmented assignment operators. Augmented assignment operators means we are performing two operations at one time. For example, instead of writing I is equal to I plus 8, we write I plus equal to 8. And your system will understand that instead of I, it will write I plus 8. Don't be confused with this one. It's not saying that I is equal to I plus 8, but it's taking the value from the right side and copying it into the memory space that is in the left side. The same for subtraction assignment, multiplication, division, and remainder assignments. What do we have? We have increment and decrement operators. What do they mean? If we put plus plus before our variable, it will mean that we are increasing our number to 1. The same thing will happen if we will write plus plus after our variable. And if you write minus minus before or after your variable, it will mean that we are decreasing our integer to into 1. For example, if here integer I is equal to 10, if we write here new number is equal to 10 times I plus plus, it will mean that our new number is I plus 1. If I is 10, it means that it is 11, and new number will be 11 times 10. It will be 110. And the same effect will be if we will put this plus plus sign before the I and after the I. Using increment operators makes expressions short, but it also makes them complex and difficult to read. Avoid using these operators in expressions that modify multiple variables or the same variables for multiple times, such as like this. In general, this increment and decrement used in loops or in such kind of statements, but it's not so good to use these increment decrement operators in long expressions because you can be confused a little bit. Numeric type conversions. Consider the following statement that, for example, we have byte, long, and double variables, and we want to make some operations between them because they are all different type of variables. We have to convert them into one type, as for example, working with different currencies. For conversion, we have 4 rules. First, if one of the operand is double, then other is converted into double. The main thing is about doubles. Otherwise, if one of the operands is float, other converted to float. And after float comes long. If one of operands is long, the other is converted into long. And the last one, if both operands are converted into integer. As you can see here, for example, double D is equal to 3. It means that this 3 will become double in this situation. Or there are two types of castings: implicit casting and explicit casting. Implicit casting, we're just writing the new type, but in the explicit casting, we're writing the type to which we are trying to change our literal in the parentheses. For example, here 3.0 is double number, but we want to change it to integer, and we are writing here in before this type of double. What's wrong here? Here, if one of the operands is double, then they become double, but integer x must be the answer must be integer. That's why here you'll have some problem. That's why to not have problem, this part of your expression you have to change into integer. Ranges by which they are increased is shown here. The byte, short, integer, long, float, and double means that the how to say the priority first of all on double, then float, and then long, and then int, and then short, and then byte. Means that if you have this kind of two types, it will be changed into double side. Write a program that displays the sales tax with two digits after the decimal point. It's just to show you you can do it at home. And this is the last part that is about augmented expressions. For example, if we have x1, some kind of operation is equal to x2 is implemented as x type of x1 and type of x1, and in the parentheses we will write the operation between these two variables where t is type of the x1. Therefore the following code will be such way that if sum is equal to 0, sum plus equal to 4.5, it becomes that this 4.5 will be the summation will be changed into integers. This is all that I wanted to explain you about the casting and variables and operations.